Good evening everyone, good evening. Welcome back everyone to JEE Enthuse. I hope you guys are doing great. Well, first of all, just let me know in the chats if I'm audible and visible to everyone, right? Just people, let me know in the chats if I'm audible and visible to everyone. Let me know in the chats fast, Hello Manisha, hello Chitra, hello Narmada, hello Abhivya, hi Ashwarya, hi Anil, hello Siddharth, hi Ishpreet. Hello Aisha, welcome back everyone, welcome back. About the N factor calculation, I'm going to give you the idea about what this oxidation and reduction actually is all about. What is oxidizing agent, what is reducing agent, everything will be done here in the tonight's session on this JEE Enthuse channel, right? So the ones who are new to the channel, let me introduce myself, people. Well, first of all, my name is Wassim and I'm your chemistry master teacher writer on this JEE Enthuse channel. The ones who have not liked the video yet, please do like the video, share the video with your friends and do subscribe to the channel, and do not forget to hit the bell icon so that you get the notification of every single session which I take live on this this JEE Enthuse channel, right? I'm still thinking I'm currently taking the session on NEET Lead, right? But this is JEE Enthuse, okay. So people, do like the video, share the video with your friends and do subscribe to the channel as well, yeah? Perfect. So let me know in the chats if you guys are super duper excited about the session. Let me know fast, people, in the chats if you guys are super duper excited for the session. Let me know fast in the chats. Which is the next chapter? Next chapter is going to be either chemical bonding or chemical equilibrium or thermodynamics. Out of these three chapters, one I'll be taking, right? Okay, perfect. All right, guys, so let's get going then. Let's get started with the today's session, right? Okay, so first of all, let me start the tonight's session by a simple statement over here, okay? What is that simple statement going to be? The statement is the oxidation state, or you can write it as the maximum oxidation state of an element, the maximum oxidation state of an element in a given compound, the maximum oxidation state of an element in a given compound can never be greater than +7 except osmium in OS, except osmium in OSO4, right? Let me tell you first of all, the maximum oxidation state of an element, it can never be greater than +7 except osmium in case of OSO4. In case of OSO4, the oxidation state of osmium, if you will calculate, see guys, let's assume the oxidation state of osmium as X, right? Oxidation state of oxygen is going to be -2. There are 4 oxygen atoms, the value comes out to be 0. The net charge on this is 0. So from here, you get the value of X as +8. So +8 is basically the oxidation state of osmium in case of OSO4, which is the exception, I must say, right? But the actual statement is the maximum oxidation state of an element in a given compound, it can never be greater than +7, except osmium in OSO4 where it is +8, right? The first and important thing. Now people, for example, I'm starting with the compound CrO5. Let's say I'm starting with CrO5. If I want you guys to calculate the oxidation state of chromium in this one, can you do that? Let's try to use the formula. Calculate the oxidation state of chromium, right? Let's assume the oxidation state of chromium is X. Since oxygen is attached to less electronegative element than itself, so oxygen will be having -2 oxygen state, right? And how many oxygen atoms do we have? 5. What is the net charge present on it? Net charge present on this is 0. The value of X over here is going to come as +10. But is the oxidation state +10 possible? It's not possible. As I told you a few minutes back, the maximum oxidation state of an element can never be greater than +7 except osmium, right? Okay. Whenever, by using the formula, the oxidation state of any element in a compound comes out to be greater than +7, what you guys are going to do at that time, you guys should know the structure of the compound, then only you can know its actual oxidation state, right? Whenever, by using the formula, the oxidation state of an element in a compound comes out to be greater than +7, at that time, you are supposed to draw the structure of the compound, right? So what is the structure of CrO5? Understand. CrO5, it has got the, as you must be familiar with the fact, it has got the butterfly type structure and it is deep blue in color as well. It is deep blue in color as well, right? And this is the structure. Cr, this is double bond O. This is one oxygen attached, one more oxygen. There's a peroxide linkage over here. Similarly, 2 oxygens attached over here, and there's a peroxide linkage right here as well. Yeah. Now you'll understand one thing. Let's assume I have got a single bond between A and B. Let's assume B is more electronegative. If B is more electronegative than A, so B will attract the bonded pair of electron towards itself. So I must say B will have the oxidation state of -1, A will have the oxidation state of +1, right? Let's say there's a double bond between A and B. And again, I'm assuming B is more electronegative than A. Again, I'm assuming B is more electronegative than A. If B is more electronegative than A, that means B has got more tendency to attract the 2 bonded pair of electrons towards itself, due to which B will have -2 charge, A will have +2 charge. Let's assume there's a triple bond between A and B, and I'm assuming B is more electronegative than A. If B is more electronegative than A, that means B will be attracting all the 3 bonded pair of electrons towards itself, due to which B will have -3 charge, A will have +3 charge, right? I hope this is clear. Now guys, understand. There's a double bond between chromium and oxygen over here. Which one is more electronegative? Chromium or oxygen? Oxygen is more electronegative. So oxygen, what it's going to do, it's going to attract the bonded pair of electrons towards itself. Since there are 2 bonded pair of electrons, so it's going to attract the bonded pair of electrons towards itself, due to which oxygen will get -2 charge. At the same time, chromium will get +2 charge due to this double bond, right? Similarly, if I talk about this single bond, chromium and oxygen being more electronegative, so it's -1, chromium will again show +1. Talking about this single bond, oxygen being -1, chromium showing +1. Talk about this single bond, this is -1, this is +1. Talking about this single bond, this is -1, this is +1, right? If I'll ask you, what is the net charge present on chromium over here? You'll say the net charge present on chromium is +2, +3, +4, +5, +6. So +6 is the net charge present on chromium in case of CrO5. Whereas when I use the formula, I got the oxidation state of chromium to be +10, which is not possible. So whenever you use the formula and get the oxidation state of an element greater than +7, at that time you are supposed to know the structure of the compound, and this is the structure of the compound, right? So if I'll ask you how many peroxide linkages are there in CrO5, what is a peroxide linkage? Oxygen single bond oxygen. Oxygen single bond oxygen is something which we call as peroxide linkage, right? Whenever 2 oxygen atoms are joined by means of a single bond, right? This single bond is what we call as peroxide linkage. Okay, so how many peroxide linkages are there in CrO5? As you can see, this is first single bond between oxygen and oxygen, so it's a peroxide linkage. One more single bond between oxygen and oxygen, one more peroxide linkage. So there are 2 peroxide linkages basically in CrO5, right? There are 2 peroxide linkages. There are 2 peroxide linkages in case of CrO5. If I'll ask you how many oxygen atoms are there with -1 oxygen state, there are 1, 2, 3 and 4. 4 oxygen atoms are there in CrO5 with -1 oxygen state, right? 4 oxygen atoms with -1 oxygen state, and there is 1 oxygen atom with -2 oxygen state in case of what? In case of CrO5, right? This is something which you should remember first of all about this CrO5, right? CrO5, it is a butterfly structure. It is deep blue in color. Oxidation state of chromium is +6. There are 2 peroxide linkages. There are 4 oxygen atoms with -1 oxygen state, and there is 1 oxygen atom with -2 oxygen state. As simple as that, right? Okay. Similarly, we have got few more structures which we are going to draw. Let's start with H2SO5. H2SO5 is something which we call as Caoci acid. H2SO5 is something which we call as Caoci acid. What is the structure of this H2SO5? What is the structure of this H2SO5? See guys, this is sulfur, double bond oxygen, right? This is oxygen attached with hydrogen. This oxygen attached with one more oxygen, and this oxygen is attached with hydrogen. This is H2SO5 structure. H2SO5. First question that can be asked, how many peroxide linkages are there in Caoci acid? There is only one peroxide linkage in Caoci acid, right? There is only one peroxide linkage in Caoci acid. And this is the peroxide linkage. Oxygen, single bond oxygen. This is the peroxide linkage in Caoci acid. There is only one peroxide linkage, right? Point number one. Point number two, have a look. If you look at this double bond between sulfur and oxygen, which one is more electronegative? You'll clearly say oxygen is more electronegative. If oxygen is more electronegative than sulfur, oxygen will have got more tendency to attract both the bonded pair of electrons towards itself, due to which oxygen will get -2 charge and at the same time sulfur will get +2 charge, right? This will be clear. Similarly, if you talk about this bond, oxygen being more electronegative, so this is -1, this is +1, right? If you talk about this double bond, this is -2, this is +2. If you talk about this single bond, oxygen being more electronegative, so -1, +1. At the same time, if you look at this bond, right? This bond pair will be exactly at the center because on both the sides we have got oxygen atoms. The tendency with which this oxygen will be attracting this bonded pair of electron towards itself, with the same tendency, this oxygen is going to attract the same bonded pair of electron towards itself. So there is no shifting of this bonded pair of electron, right? Okay. Now we will at the same time, if you look at this bond between oxygen and hydrogen, oxygen being more electronegative, right? So it will attract this bonded pair of electron towards itself, due to which it gets -1 and hydrogen gets +1, yeah? Similarly, over here hydrogen gets +1, oxygen gets -1. So what is the net charge present on this oxygen? Net charge present on this oxygen is -2. What is the net charge present on this oxygen? It's -2. What is the net charge present on sulfur? Net charge present on sulfur is +2, +3, +5, +6. +6 is the net charge present on sulfur. What is the net charge present on this oxygen? It's -1. What about this one? It's -1. What about the net charge present on this oxygen? It is -2. What about the charge present on this hydrogen? It's +1. What about the charge present on this hydrogen? It's +1. I got the oxidation states of all the elements. I got the oxidation states of all the elements in this compound, right? That's something which I was supposed to check, yeah? Right? You can say the oxidation state of sulfur in H2SO5 in Caoci acid is +6, right? How many peroxide linkages are there in H2SO5? There is one peroxide linkage. How many oxygen atoms are there with oxidation state of -2? There are two oxygen atoms, sorry. How many oxygen atoms are there with the oxidation state of -1? There are two oxygen atoms in case of H2SO5 with the oxidation state of -1, right? How many oxygen atoms are there in H2SO5 with the oxidation state of -2? This is the one, this is the one, and this is the one. So there are three oxygen atoms with the oxidation state of -2. All these can be asked out of this, right? I'm sure it's clear to everyone. Right, people? Yeah? I'm sure it's clear to every single guy, yeah? Perfect. So let's move on to one more structure then. Let's move on to one more structure. The another one is going to be Marshall's acid. In Marshall's acid, anything can be asked out of these things, right? Anything can be asked. You can be either asked the oxidation state of sulfur. You can be asked about the number of peroxide linkages. You can be asked, how many oxygen atoms are there with -1 oxygen state? How many oxygen atoms are there with -2 oxygen state? Anything can be asked, but if you know its structure, you can answer every single question from this, right? Okay, now have a look exactly. If you talk about the Marshall's acid, its structure is going to be like this. S double bond O. This is double bond O. Oxygen, oxygen. This is S double bond O. This is double bond O. This is oxygen, which is attached with hydrogen. And this is oxygen, and this attached with hydrogen as well, right? So this is basically the structure of your H2S2O8. Now we can calculate every possible thing which can be asked from this, right? Okay. Now let's see what all things can be asked. Let me start with this sulfur. There's a double bond between sulfur and oxygen. Oxygen being more electronegative. It will attract both the bonded pair of electrons towards itself, due to which it gets -2 and sulfur gets +2. If you talk about this double bond, oxygen more electronegative, so it will be having -2, this one is going to have +2, right? If you talk about this single bond between sulfur and oxygen being more electronegative, so -1, this is going to be +1, right? If you talk about this single bond between sulfur and oxygen being more electronegative, so -1, +1, right? So what is the net charge present on this sulfur? Net charge present on this sulfur is going to be +2, +3, +5, +6. It's going to be +6, right? Okay. Now, if you look at this bond between oxygen and hydrogen is more electronegative, due to which it will get -1, and hydrogen at the same time will get +1. So this oxygen is having the oxidation state of -2. Even this oxygen is having the oxidation state of -2. Even this oxygen is having the oxidation state of -2, right? Okay. Let's look at the other bonds as well. See, this is a single bond between oxygen and oxygen. So it is not going to contribute towards the any charge present on this oxygen or this oxygen, because the bond pair is exactly going to be at the center, right? Because on both the sides of this bond pair, you have got two similar atoms, right? Okay. Now we will have a look. If you look at this sulfur, S double bond O, oxygen being more electronegative, so -2, sulfur at the same time will have +2. If you look at this double bond, -2, sulfur will have +2. If you look at this single bond, oxygen will have -1, sulfur will have +1. If you look at this single bond, oxygen will have -1, sulfur will have +1. If you look at this single bond, oxygen -1, hydrogen +1. Let's calculate the oxidation states of all the elements, right? See, what is the oxidation state of this hydrogen? What is the charge present on this hydrogen? +1. Charge present on this oxygen, it's -2. That means the oxidation state of this oxygen, -2. Charge present on this oxygen, it's -2, right? Charge present on this sulfur, +2, +3, +5, +6, right? Charge present on this oxygen, -1. Charge present on this oxygen, -1. Whatever can be asked, I have written every single thing over here for you, right? Okay. Now people, if I'll ask you, what is going to be the oxidation state of sulfur in case of H2S2O8? Oxidation state of sulfur is going to be +6, right? Similarly, oxidation state of this sulfur is going to be +6. If I'll ask you, what is going to be the average oxidation state of sulfur? Average oxidation state of sulfur is going to be total charge present on the sulfur atoms, which is +6 divided by number of sulfur atoms, that is 2, right? So the value finally comes out to be +6. So +6 is basically the average oxidation state of sulfur, right? If I'll ask you, how many oxygen atoms are there with -1 oxidation state? This oxygen atom and this oxygen atom. These two oxygen atoms are there in -1 oxygen state. So there are basically two oxygen atoms with -1 oxygen state. If I'll ask you how many peroxide linkages are there, you'll say there is only one peroxide linkage. That is this linkage, right? Okay. I'm sure everything is clear to everyone. Yeah? Now Vivek is saying how to check which element is more electronegative and which element is less electronegative. Vivek, remember, fluorine is the maximum electronegative element among all the elements in the periodic table, followed by oxygen, followed by nitrogen. Do remember this thing, and at the same time remember one more thing. On moving from left to right, electronegativity increases. On moving from left to right in the periodic table, generally electronegativity increases. On moving from top to bottom, electronegativity decreases. Just remember these two things. You can easily check it out, which element has got more electronegativity and which element has got the less electronegativity among all. I'm sure this is again clear to you, right? Yeah? I'm sure it's clear. I'm directly moving on to one more structure then. The structure of S4O6 di-negative, right? What is going to be the structure of S4O6 di-negative? Have a look, guys. This is sulfur, double bond oxygen. This is double bond oxygen. Sulfur attached with one more sulfur, one more sulfur, one more sulfur. This is double bond O. This is double bond O. Oxygen carrying the negative charge. Oxygen carrying the negative charge, right? This is the structure of S4O6 di-negative. S4O6 di-negative, right? Now we will have a look exactly on what all things I'm going to tell you now. First of all, let's have a look on this double bond, sulfur and oxygen. Oxygen is more electronegative than sulfur. So oxygen has got more tendency to attract the bonded pair of electron towards itself, due to which it's going to get -2 and this sulfur will get +2. Due to this double bond, oxygen will get -2, sulfur will get +2, right? Due to this single bond, oxygen will get -1, sulfur will get +1. Due to this single bond, nothing is going to happen because on both the sides you have got sulfur atoms, right? Similarly, over here nothing is going to happen on both the sides sulfur atoms, on both the sides sulfur atoms, right? Now due to this double bond, oxygen will have minus 2 charge, sulfur will have plus 2 charge. Due to this double bond, oxygen will have minus 2, sulfur will have plus 2. Due to this single bond, oxygen will have minus 1, sulfur will have plus 1, right? If I'll ask you, what is the net charge present on this sulfur? You'll clearly say net charge present on this sulfur is going to be plus 2, plus 2, plus 1, that is plus 5, right? Similarly, if I'll ask you what is the net charge present on this sulfur, you'll say it's again going to be plus 5. If I'll ask you what is the net charge present on this sulfur, you'll say it's 0. Again, this is 0, right? Okay. So you got the oxidation states of all the sulfur atoms in this compound, right? Now, if I'll ask you what is going to be the average oxidation state of sulfur, you'll clearly say average oxidation state of sulfur is going to be equal to total charge present on the sulfur atoms, which is plus 5, plus 0, plus 0, plus 5 divided by number of sulfur atoms, that is 4. The value comes out to be plus 2.5. So plus 2.5 is basically the average oxidation state of sulfur in case of S4O6 dinegative, right? Okay. I'm sure everything is clear till here. Yeah? Okay. This was about what? S4O6 dinegative, right? Well, from the same concept, the question was asked long back in your JEE Mains, right? The question was the correct set of oxidation states of sulfur in Na2S4O6. Na2S4O6. Few options were given to us. The first option was given to us as plus 5, 0, 0, plus 5. Second option that was given to us was plus 5, 0 and 0. Third option that was given to us 0, 0, plus 5, and last option you can write none of the above, right? You need to select the correct answer among all. What is going to be the correct set of oxidation states of all the 4 sulfur atoms in case of Na2S4O6? You can only solve this question. Yesterday's class recording. What are you talking about? Okay, see guys. You need to know the structure of Na2S4O6 first of all. This is the structure of Na2S4O6. This is the structure of Na2S4O6, right? And once you know the structure of Na2S4O6, you can calculate the oxidation state of this sulfur, which will come out to be plus 5. This will come out to be 0. This will come out to be 0, and this will come out to be plus 5, right? So what is going to be the correct set of correct set of oxidation states of these 4 sulfur atoms? It's going to be plus 5, 0, 0, plus 5, right? So plus 5, 0, 0, plus 5 is going to be the correct answer of this question. I'm sure it's clear to everyone, right? Absolutely, option A is going to be the answer. Right, people? Let's have a look on few more important structures. Bleaching powder, CaOCl2, right? CaOCl2. You need to remember its structure as well. This is Ca, this is O, right? This is Cl, and this Cl is directly attached with this Cl is directly attached with calcium. This is the structure of CaOCl2. Now there is one interesting thing to note. See guys, if I look at this bond between oxygen and chlorine, oxygen being more electronegative, it is going to have the oxygen state of -1. Chlorine being less electronegative, it's going to have +1, right? Due to this single bond, oxygen being more electronegative, so -1 +1. Due to this single bond, chlorine being more electronegative, so this is -1 and this is +1, right? What is the charge present on this calcium over here? It's +2. So +2 is going to be the oxidation state of this calcium. What is going to be the net charge present on this oxygen? It's going to be -2. So -2 is going to be the oxidation state of this oxygen. What about the oxidation state of this chlorine? It's going to be -1. What about the oxidation state of this chlorine? It's going to be +1, right? So these 2 chlorine atoms over here in bleaching powder, one is going to have the oxidation state of -1 and one is going to have the oxidation state of +1, right? Right, people? Yeah? Okay, if I'll ask you what is going to be the average oxidation state of chlorine in case of bleaching powder? What is going to be the average oxidation state of chlorine in the bleaching powder? What it's going to be? What it's going to be? See, what is the net charge present on chlorine? +1 and -1. +1, -1, right? So +1, -1 divided by 2 chlorine atoms. So the average oxidation state of chlorine will come out to be 0, right? Average oxidation state of chlorine in bleaching powder is coming out to be 0. That does not mean there is no charge on chlorine. right? This is the average which comes out to be 0, okay, right? Okay, from the actual structure, you are getting to know on one chlorine atom the charge is +1, on another chlorine atom the charge is -1, which eventually cancels out, right? And the average oxidation state of chlorine in bleaching powder becomes 0, right? I'm sure it's clear to everyone, yeah? Absolutely, guys. Moving on to a few more structures, yeah? Moving on to a few more structures. Structure of BaSCN whole twice, right? Structure of BaSCN whole twice. Well, people, this is the structure of BaSCN whole twice. This is Ba, this is S, this is C, this is triple bond nitrogen, this is S, this is C, this is triple bond nitrogen over here. This is your BaSCN whole twice, right? Well, guys, if you look at this triple bond between carbon and nitrogen, nitrogen being more electronegative, it's going to attract all the 3 bonded pair of electrons towards itself, due to which it will have -3, and at the same time carbon will have +3, right? Similarly, due to this triple bond, nitrogen is going to attract these 3 bonded pair of electrons towards itself, due to which it gets -3, carbon is going to have +3. Due to this single bond between carbon and sulfur, sulfur is more electronegative, so sulfur is going to have -1, carbon is at the same time going to have +1. Sulfur over here -1, carbon +1. Due to the bond between barium and sulfur, sulfur again being more electronegative will have -1, barium due to this bond will have +1. Similarly, due to this bond, it's going to be -1, this is going to be +1. What is the net charge present on this barium right here? It's +2. What is the net charge present on this sulfur over here? It's going to be -2. What is the net charge present on this carbon over here? It's going to be +4. What is the net charge present on this nitrogen over here? It's -3, right? Similarly, this nitrogen, -3 oxidation state, this carbon, +4 oxidation state, right? This sulfur, -2 oxidation state, okay? So you got the oxidation states of all the elements which are involved in case of this structure, which is BaSCN whole twice. I'm sure it's again clear to everyone, right? Yes, Sandila, I'll be from now onwards, I'll be taking the classes daily. Yes, absolutely. Wassim sir, when is the next advanced topic session? Well, on Monday, I'm coming up with some 15 JEE advanced asked questions, right? Okay, from different chapters. So on Monday at 10:30, I'll be doing one more advanced session from different chapters, okay? It's going to be a different chapter session. Right? Vivek is saying how to arrange elements in formula. What? I'm not getting you. Perfect, guys. So let's move on to a few more structures. Then this was about BaSCN whole twice. Now the structure of H2SO4 you all must be knowing, right? In case of H2SO4, sulfur is going to have the oxidation state of +6, right? This is something which I'm not going to show you exactly. This is your H2SO4. I'm not going to talk about this one. Okay. See, let's talk about the structures of these acids of phosphorus, right? I'll be making the structures of the acids of phosphorus starting from H3PO2, H3PO3, H3PO4 and H3PO5, right? In order to make any of the structure among all, first thing which I'll be doing, I'll be putting a double bond between phosphorus and oxygen. Everywhere I'll be putting a double bond between phosphorus and oxygen, right? Everywhere I'm putting the double bond between phosphorus and oxygen. Okay, now, if I need to make the structure of H3PO2, this is going to be one of the oxygen attached with hydrogen, and there will be 2 more hydrogens, right? One hydrogen directly attached with this one more hydrogen directly attached with this one. This is basically your H3PO2. This is basically your H3PO2. Similarly, what about H3PO3? This is, for example, oxygen, this is hydrogen, right? Okay, this is oxygen, this is hydrogen, right? And this hydrogen is attached directly with phosphorus. This is the structure of your H3PO3. Similarly, if you look at the structure of H3PO4, this is oxygen, this hydrogen, this oxygen, this hydrogen, and this is oxygen, this is hydrogen. This is the structure of your H3PO4, right? Now talking about the structure of H3PO5, this is oxygen which is attached with hydrogen, one more oxygen attached with hydrogen, and there will be one more oxygen which is attached with oxygen which is attached with hydrogen. This is the structure of your H3PO5. These are the structures of the different acids of phosphorus which I have made over here. Now, one by one, let's try to calculate the oxidation state of phosphorus in all these species over here. Understand what I'm going to do, okay? See guys, first thing, let me tell you, Between phosphorus and hydrogen, let me tell you, phosphorus is more electronegative, right? Between oxygen and phosphorus, let me tell you, oxygen is more electronegative, right? Okay. And between oxygen and hydrogen, let me tell you, oxygen is more electronegative. This is something which you all must take a note of, right? Now let's try to solve this. This is P double bond O. P double bond O. Oxygen being more electronegative, it will attract both the bonded pair of electrons towards itself, due to which it will have -2. This is going to have +2, right? Phosphorus and oxygen, single bond. So this is -1. This will be +1, right? Okay. What about this bond? Oxygen and hydrogen. Again, oxygen will have -1, hydrogen will have +1. Phosphorus and hydrogen. Phosphorus is more electronegative than hydrogen. So phosphorus, due to this bond, will have -1. Hydrogen will have +1. Again, due to this bond, -1 and +1. What is the net charge present on phosphorus? Have a look on it. What is the net charge present on phosphorus? +2, +3, +2, +3, -1, -1. How much it comes out to be? It comes out to be finally +1. So +1 is the oxidation state of phosphorus over here. If I'll ask you what is the oxidation state of this oxygen, you'll say it's going to be -2. What is the oxidation state of this oxygen? -2. What about the oxidation state of these hydrogen atoms? It's going to be +1. As simple as that, right? Yes. Similarly, guys, if you look at this structure, P double bond O, oxygen being more electronegative, right? Oxygen being more electronegative. So it will have -2. This will have +2. Due to this single bond, -1, +1. Due to this single bond, -1, +1. Due to this single bond, it's going to be, due to this single bond, phosphorus is first of all more electronegative, so it's going to be -1, it's going to be +1. What is the net charge present on phosphorus? +2, +1, that means +3. +3 and this 1 gets cancelled, so +3 is the oxidation state of phosphorus over here. +3 is the oxidation state of phosphorus. Rest you can calculate, you can calculate the oxidation states of all the other elements, right? Yes, Priyanka, I'll be coming up with the one-shot IUPAC nomenclature as well, yeah? Okay, see, this is P double bond O. Oxygen will have -2, phosphorus will have +2, right? Oxygen being more electronegative. Talking about this single bond, -1, +1. Talking about this single bond, -1, +1. Talking about this single bond, -1, +1, right? Calculate the net charge present on this phosphorus. It's going to be +2, +3, +4, +5, right? So +5 is going to be the oxidation state of phosphorus in case of H3PO4, right? Similarly, if I need to calculate the oxidation state of phosphorus in H3PO5, you can clearly calculate it as +5, right? And you can see one peroxide linkage over here in case of H3PO5 as well, right? There is one peroxide linkage. There is one peroxide linkage in case of H3PO5. There are two oxygen atoms in case of H3PO5 which are present in -1 oxidation state. And what are those oxygen atoms? This is the one, this is one more. There are two oxygen atoms in case of H3PO5 wherein oxygen states of oxygens are -1. Yeah, I'm sure it's again clear to everyone. These were the structures of phosphorus which you need to remember in order to calculate the oxidation state of phosphorus in these compounds, right? Okay. Harshita is saying how to calculate the oxidation number of CrO6. Okay. If you talk about CrO6, CrO6 structure is like this. Right? I'm making the structure of CrO6. This is the structure of your CrO6, yeah? This is the structure of your CrO6. You can calculate it. Now you can calculate the oxidation state. Have a look properly. Chromium, single bonded oxygen. Oxygen being more electronegative, -1. Chromium will at the same time will have +1. Oxygen being more electronegative, -1. Chromium +1. Oxygen more electronegative, -1, +1. Oxygen more electronegative, -1, +1. Everywhere it's -1, +1, -1, +1, right? This is -1, this is +1. What is the net charge present on chromium? 1, 2, 3, 4, 5, 6. So +6 is the net charge present on chromium in case of CrO6. If I'll ask you how many peroxide linkages are there in CrO6, this is first peroxide linkage, second peroxide linkage, third peroxide linkage. So there are 3 peroxide linkages present in CrO6. How many oxygen atoms are there in CrO6 having -1 oxidation state? All the 6 atoms, all the 6 oxygen atoms in CrO6 have got the -1 oxygen state. Anything can be asked out of these things, right? Right, people? I'm sure it's clear to everyone. Yeah? Which book is the best? For physical chemistry, you can go for N-Avasthi, right? Okay, for organic, you can go for Solomon Freil. Okay, and for inorganic, J.D. Lee is the best, right? Okay. So I'm sure everything is clear till here, people. Let me move on to few more. Structure of K3CrO8. Structure of K3CrO8. Understand. See guys, first of all, let me use the formula and calculate the oxidation state of chromium. See, potassium, it belongs to group first. Group first elements, they show +1 oxygen state, and we have got some 3 potassium atoms. Let's assume the oxidation state of chromium is X, right? Oxidation state of oxygen is -2, and there are some 8 oxygen atoms. Net charge present on the molecule is 0. What is the value of X which you will get from here? 8 2s are 16, right? So 16 X value from here comes out to be how much? It comes out to be +13, right? Can the oxidation state of element be +13? Can the oxidation state of element be +13? I told you a few minutes back only. I started the session with a statement. Oxidation state of an element, the maximum oxidation state of an element in a given compound can never be greater than +7 except in case of osmium in OSO4, right? So if the oxidation state of chromium cannot be +13, then how you are going to calculate its oxidation state? In order to calculate the oxidation state of chromium, what do you need exactly? You need the structure of K3CrO8. And what is the structure of K3CrO8? This is chromium, this is oxygen, this is oxygen, there is a peroxide linkage. Oxygen, oxygen, this is potassium. Oxygen, oxygen, this is potassium. Oxygen, oxygen, this is potassium. This is K3CrO8, right? This is K3CrO8. Now let's calculate the oxidation state of every element. Let me tell you, this chromium right here is going to be in +5 oxygen state, because everywhere you have got single bond oxygen attached, single bond oxygen, right? See, this is a peroxide linkage, this peroxide, this peroxide, this peroxide, and whenever oxygen is in peroxide linkage, generally it shows the oxidation state of -1. So this -1, this is -1, -1, -1, everywhere it's -1. So since there are 4 peroxide linkages, that means there will be total 8 oxygen atoms with -1 oxidation state. I'm sure this is again clear to everyone, right? Okay. Sharik, I'll be doing it soon, just wait for it. How do I draw these structures? People, you have to remember these structures, right? You have to remember these structures. There is no shortcut towards the structures. Do practice the structures, they'll automatically get remembered, okay? Yeah? Perfect? All right. Moving on to something called as oxidation and reduction, right? This is something which you study in your class 9th as well. Let me give you the basic idea of oxidation and reduction, then I'll move on directly to something called as oxidizing agents, reducing agents, and some important stuff, yeah? Sir, please repeat the book for organic. Solomon Freil, yeah? Okay? See guys, how do we define the term oxidation? Oxidation is defined in many ways. Any process which involves loss of electrons, any process in which loss of electrons is happening is what I call as oxidation. Loss of electrons is what I call as oxidation. Addition of oxygen is also called as oxidation, right? Removal of hydrogen, also called as oxidation. Addition of more electronegative element, also called as oxidation, right? Similarly, gain of electrons, reduction, right? Addition of hydrogen, reduction. Removal of oxygen, reduction. Removal of more electronegative element, reduction. All these are basically the definitions of your what? Of your oxidation and reduction. But you're not supposed to remember all. Just remember one definition. Loss of electrons is what I call as oxidation. Gain of electrons is what I call as reduction. Loss of electrons, oxidation. Gain of electrons, reduction, right? This is the definition which I need in this chapter. All the other definitions, I do not need them, right? I need only one definition. Loss of electrons involves oxidation. Gain of electrons means reduction, yeah? Now people understand. Let me take certain examples. See, if you look at these examples, for example, have a look. Magnesium, it does not have any charge on it, so its oxygen state is 0. Magnesium, it has got +2 charge on it, its oxygen state is +2, right? So 0 to +2, 0 to +2. Is the oxidation state of magnesium increasing from 0 to +2? Absolutely. Oxidation state of magnesium is increasing from 0 to +2, as you can see, right? Similarly, guys, have a look. Calcium, it does not have any charge, its oxygen state is 0. What about the oxidation state of calcium over here? X minus 2 is equal to 0, X value will come out to be plus 2. So 0 to plus 2. Is the oxidation state of calcium increasing? Absolutely it's increasing, right? If you look at this one, what about the charge on carbon? 0. What about the charge on carbon over here? X minus 4 is equal to 0, X value is plus 4, 0 to plus 4. Again the oxidation state of carbon is increasing, right? Okay. First of all, the first example involves the loss of electron, oxidation. Second example involves the addition of oxygen, oxidation process. Third example involves the removal of hydrogen. This process is also called as oxidation. And the fourth example involves the addition of more electronegative element. This one is also oxidation. Now there is something common in everyone. There is something common to everyone. See, can I say over here oxidation state of element is increasing? Over here also oxidation state is increasing. Over here also oxidation state increasing. And there also oxidation state you'll find out to be increasing. So I can define oxidation in another way as well. I can simply say increase in the oxidation state of an element. Increase in the oxidation state of element is something which we call as oxidation. In short, increase in the oxidation state of an element is what we call as oxidation. Similarly, decrease in the oxidation state. Decrease in the oxidation state of an element is what I call as reduction. Okay? Oxidation means loss of electrons. Reduction means gain of electrons. As simple as that, right? Okay? Yeah? Yes, Vivek, exactly. I'm sure this is clear to everyone. So increase in the oxidation state of an element is what we call as oxidation. Decrease in the oxidation state of an element is what we call as reduction. I want you guys to remember this thing over here, right? Yeah? Now, moving on. In oxidation, the oxidation state of an element increases. In reduction, the oxidation state of an element decreases. This is something which you must be familiar with now. Okay? Now let's move on to something called as oxidizing agent and reducing agent. And how do we identify which one is oxidizing agent, which one is reducing agent, right? Let me give you the definition of this oxidizing and reducing agent. This is something which you would have discussed in your earlier class as well, right? Still, I'm just quickly recapping those things. Oxidizing agent is the one which oxidizes others but itself undergoes reduction. Again, I'm repeating. Oxidizing agent is the one which oxidizes others but itself undergoes reduction, right? For example, I'm the oxidizing agent. I'm the oxidizing agent. So I'm oxidizing the other person and myself I'm getting reduced, right? Okay? Oxidizing agent is the one which oxidizes others, itself undergoes reduction. Reduction means gain of electrons. That means I'm gaining electrons. I'm making the other person to lose electrons, right? Similarly, if I talk about the reducing agent is simply the one which reduces others but itself undergoes oxidation, right? For example, I'm the reducing agent, right? Reducing agent reduces others. It makes the other person to gain electrons, but itself it loses electrons, yeah? Okay? Right? This was the definition. Let me give you the example by means of which you get the clear picture of what this oxidizing and reducing agent is all about, right? Okay, understand. See guys. For example, I'm writing a reaction like this. A plus B. A plus B gives A positive plus B negative. Gives A positive plus B negative. I'm assuming this A and B right here to be in their elemental state, to be in their standard state. Let's assume this A is right here in its standard state, so its oxygen state is going to be 0. B right here is in its standard state, its oxygen state is, for example, 0. What is the charge present on this A? Plus 1. So plus 1 is the oxygen state of A right here. Charge present on this B, it's minus 1. So minus 1 is its oxygen state. So during this process, is the oxidation state of A increasing or decreasing? It's increasing. Is the oxidation state of B increasing or decreasing? It's decreasing. Increase in the oxidation state is what we call as oxidation. So I can say A is undergoing oxidation. A is undergoing oxidation. That means decrease in the oxidation state of B. B is undergoing reduction. Remember, that substance which undergoes oxidation is what I call as a reducing agent, and that substance which undergoes reduction is what I call as oxidizing agent, in short, right? Okay? I'm sure every single thing is clear till here, right? Now guys, have a look on this one. Magnesium, it does not have any charge on it, so its oxygen state is 0. Oxygen, it does not have any charge on it. This oxygen is present in its standard state. Its oxygen state is 0. Magnesium, if you calculate its oxygen state, x minus 2 is equal to 0. So x value will come out to be plus 2, right? Oxidation state of oxygen, right here, it's minus 2, right? Is the oxidation state of magnesium increasing or decreasing? Oxidation state of magnesium is increasing from 0 to plus 2. Oxidation state of oxygen, what is happening to the oxidation state of oxygen? It is decreasing. Increase in the oxidation state is what we call as oxidation. So magnesium is undergoing oxidation. This oxygen is undergoing reduction, decrease in the oxygen state. The one which undergoes oxidation is what we call as a reducing agent. The one which undergoes reduction is what we call as oxidizing agent. So are you identified properly which one is oxidizing and which one is reducing? As simple as that, right? Okay. I'm sure it's clear to everyone. Let me know in the chat, people, if it's clear fast. Yeah? Let me know fast in the chats if it's clear. Okay. Let's take few of the examples and let's try to understand which one is the oxidizing agent, which one is the reducing agent. How do we identify them? See guys, let me calculate the oxidation state of every single species over here, right? Let's calculate the oxidation state of this iron. It's going to be X. Oxidation state of oxygen is 2. So minus 2 is equal to 0. So oxidation state of iron is going to be plus 2. What about the oxidation state of this oxygen? It's going to be minus 2, right? Oxidation state of manganese, when you calculate it, it's going to be X. Chalo, I'll show it to you, right? Let's assume the oxidation state of manganese is X. Oxidation state of oxygen is going to be minus 2. So there are 4 oxygen atoms. The net charge present is minus 1. So X value will come out to be plus 7. So this plus 7. What about the oxidation state of oxygen? Minus 2, right? Minus 2. Hydrogen, oxygen state plus 1. Chlorine, oxygen state minus 1, right? Iron, its oxygen state when you will calculate, it's 2x minus 6 is equal to 0. So X value will come out to be plus 3. So this will be minus 2. I hope you know now how to calculate oxygen state from the formula, right? Okay. Now similarly, if I talk about this MnCl2, over here manganese is attached with a more electronegative element, which is chlorine, right? So let's calculate the oxidation state of manganese over here. Let's assume its oxygen state is X, right? Chlorine will definitely show minus 1 oxygen state and we have got two chlorine atoms. Net charge present on this MnCl2 is absolutely going to be 0, right? So what is going to be the value of X over here? It's going to be plus 2. So manganese shows plus 2 oxygen state, chlorine shows minus 1 oxygen state. What about water? This is something which is very evident, right? This oxygen state of oxygen right here is going to be minus 2 and hydrogen shows plus 1. I wrote the oxidation states of all the possible elements, right? Okay. I wrote the oxidation states of all the possible elements in the given compounds, right? Now we will understand few important things. Is the oxidation state of iron changing or not? Yes, it's changing. Yes, it's changing, right? Oxidation state of iron is changing from plus 2 to plus 3, right? So is there increase in the oxidation state of iron or not? Yes, there is increase in the oxidation state of iron. Yeah. What is happening to the oxidation state of oxygen? Minus 2. Over here it's also minus 2. Over here it's also minus 2. So there is nothing happening towards the oxidation state of oxygen. There is no change in the oxidation state of oxygen. So I've got nothing to do with the oxygen right here. Okay. Similarly, if you talk about manganese, its oxygen state right here is plus 7. Right? And over here, it's plus 2. So plus 7 to plus 2. Is there increase in the oxygen state or decrease? There is a decrease in the oxygen state. Right? We all are familiar with the fact increase in the oxidation state of the element is what we call as oxidation. So I must say this FeO over here is undergoing oxidation and this MnO4 negative over here is undergoing reduction, and that substance which undergoes oxidation is what I call as a reducing agent, and that substance which undergoes reduction is what I call as oxidizing agent. As simple as that, right? Okay, I'm sure it's clear to everyone. Cool? All right, one more example I'm taking, right? One more example I'm taking. Let's try to identify which one is the oxidizing and reducing agent. Now people, you must answer this fastly, okay? Right? I hope you got the concept properly. Now it's time to identify which one among the two is going to be oxidizing agent and reducing agent, yeah? Okay? Alright. So we will have a look properly. Is there any charge on zinc? Zinc is right here present in its standard form. And we know when the element is present in its standard form, its oxidation state is taken to be 0. So absolutely, zinc is going to have 0 oxidation state right here. Okay. Similarly, there is a charge plus 2 on this copper. So plus 2 is going to be the oxidation state of copper. Over here, plus 2 oxidation state of zinc. Right here, 0 oxidation state of copper. Yeah. So is the oxidation state of zinc increasing or decreasing? 0 to +2. Absolutely, oxidation state of zinc is increasing, right? But what is happening to the oxidation state of copper from +2 to 0? Oxidation state of copper is decreasing. We know increase in the oxidation state of the substance is what we call as oxidation. So I must say the zinc is undergoing oxidation. So decrease in the oxidation state of an element is what we call as reduction. So you can clearly say the Cu dipositive undergoes reduction. That substance in a chemical reaction which undergoes oxidation acts as the reducing agent, and that substance in a chemical reaction which undergoes reduction acts as the oxidizing agent, right? As I have already given you the definitions, right? Reducing agent is the one which reduces others. Reducing agent is the one which reduces others but itself undergoes oxidation. Similarly, oxidizing agent is the one which oxidizes others but itself undergoes reduction. As simple as that, yeah? Okay. For example, let me take one more example. Let's say I've got something as MnO4 negative plus I negative plus H positive. Let's assume it gives Mn di positive plus I2 plus H2O, right? Let's identify which one among the two is oxidizing agent and which one among the two is a reducing agent. First thing, what you'll be doing, you'll be calculating the oxidation state of every species over here. Let me tell you, oxidation state of manganese over here, you'll calculate it to be +7, right? Oxidation state of iodine -1, manganese over here +2, iodine over here is 0, right? Now check it out. +7 to +2, decrease in the oxidation state. That means this MnO4 negative is undergoing reduction, right? I negative, -1 to 0, increase in the oxidation state. Increase in the oxidation state is what we call as oxidation. So this is undergoing oxidation, right? This is undergoing reduction. So if this is undergoing reduction, it's going to be the oxidizing agent. If this is undergoing oxidation, this is going to be the reducing agent. As simple as that, right? Right, people? Absolutely. Yeah? Okay, equivalent concept is something which I'll be teaching you in the next session. One homework I'm going to give you. Do let me in the comment section, okay, which one is going to be the oxidizing agent and which one is going to be the reducing agent. The homework which I'm giving you right here, that's going to be KMnO4 plus H2C2O4 plus H positive. It gives Mn di positive plus CO2 plus H2O. You need to identify among these two reactants which one is the oxidizing agent and which one is the reducing agent. This is your homework. Do let me know its answer in the comment section. And in the tomorrow session, we'll be dealing with something called as equivalent mass, right? We'll be talking about something called as the calculation of N factors, which is very, very important, right? So with this, people, I will be taking a leave, right? And talking about the pro subscription, the link is there in the description box of the video. You guys can click on the link, right? You guys can click on the link, get added to the long-term batches, okay? And let me show you exactly what all things are there which you need to take into consideration. See, guys, so basically, if you want to join the actual Vedantu classrooms, apart from all these YouTube sessions, right, you are supposed to take any one of these plans, light, classic or plus. You can take any one of these plans. What is the difference between them, right? In case of light plan, this is basically for the ones who are going to write JEE in 2023, and all these plans are first of all the 2-year classroom programs, right? This is the course fee for these 2 years, and you can pay this much of amount in installments as well, right? Vedantu has kept an option for that. Similarly, this is the course fee for the classic one for 2 years. You can pay this much of amount in installments. Even this much of amount you can pay in installments, right? Vedantu has kept an option for that, yeah? And if you're new to Vedantu, you have no idea how the actual Vedantu classrooms look like, right? What I would suggest for you guys, I would suggest you guys to take any of these plans for a month, right? You can take these plans for a month, right? And this is the course fee for the month, right? For all these plans. If you wanna take this plan, light plan for a month, you have to pay 2,700 something, right? Use the coupon code WBPRO enrollment, right? Okay, and if you are using this coupon code WBPRO, you'll be getting some additional 10 to 20% off while enrolling. Let me exactly show you how to get enrolled in the actual Vedantu classrooms by means of any of these plans, right? This is the video which you guys are currently watching, I believe, yeah? This is the video which you guys are currently watching, yeah? You need to click on this show more. After clicking on this show more, what you need to do is, there you'll find a link. of Pro subscription. Subscribe to Vedantu Pro now. Click on this link, right? After clicking on this link, just drag it a little down. You'll be finding 3 plans: Light, Classic, and Plus. If you want to go for Light, yeah, you can try it out for a month, or you can buy complete course, but use the coupon code WSPRO while enrolling, right? Yes, Vivek, till December syllabus will get completed, right? On the actual Vedantu platform, yeah? So, or else you can take the complete course in the form of EMI. EMI starts at 3,000 per month, something like that. So do use this coupon code BPRO. For example, if I need to go for the Light for a month, I need to click on this. I need to put my phone number or email ID on which I will get the OTP and everything and get enrolled in the long-term platform on the actual Vedantu platform with us, right? Okay. So there is one more link in the description box, that is for the Telegram. Do click on this link, get added to the Telegram group and stay updated about the classes. The ones who have not liked the video yet, please do like the video, share the video with your friends, and do not forget to subscribe to the channel. Well, I'll see you guys tomorrow at the same time at 10:30 night, in which we'll be discussing the equivalent mass and the calculation of n factors, which is very, very important topic from the chapter Redox, right? So with this, I'll be taking a leave. See you guys tomorrow. Till then, you guys take care. Bye-bye. God bless you all and love you all. Take care, guys. Bye.